NFPA 70-2021, which is the National Fire Protection Association's standard for electrical safety in the workplace, mandates specific requirements for arc flash warning labels on electrical panels. These requirements are designed to ensure that workers are adequately informed about the potential arc flash hazards associated with electrical panels and have the necessary information to protect themselves if an arc flash event occurs. The label's position is critical. Labels must be affixed to the exterior of the electrical panel door or cover. This ensures that the warning is immediately visible before anyone opens the panel. The standard specifies a minimum label size of 4 inches by 6 inches. This size ensures that the information on the label is easily readable from a reasonable distance. The label must contain key information related to arc flash hazards. Firstly, the label must display the incident energy, measured in calories per square centimeter. This value represents the amount of thermal energy a worker could be exposed to during an arc flash. Secondly, the arc flash boundary, measured in feet, must be indicated. This boundary defines the distance from the energized equipment within which a person could receive a second-degree burn if an arc flash were to occur. Thirdly, the required personal protective equipment, or PPE category, must be specified. This category indicates the level of protection needed to safely work on or near the energized equipment. Fourthly, the date the arc flash analysis was performed must be included. This date allows workers to assess the currency of the information, as electrical systems can change over time, affecting the arc flash hazard levels. Fifthly, the name of the qualified person who conducted the arc flash analysis must be provided. This allows for verification and clarification of the analysis results if needed. The labels must be clearly visible and not obstructed by other markings or any obstructions. This ensures that the warning is easily noticeable. Durability of the label is also important. The labels must be made of a durable material that can withstand environmental conditions and resist fading, tearing, and other forms of damage. This ensures that the information remains legible over time. These requirements are put in place to protect workers from arc flash hazards. Arc flash is a dangerous phenomenon that can occur when electrical equipment malfunctions, resulting in a sudden release of energy. This energy can cause severe burns, electrical shock, and even death. By providing clear and readily available information about arc flash hazards, these labels empower workers to take appropriate precautions and protect themselves. The incident energy is a critical parameter on the label. It indicates the amount of thermal energy that could be released during an arc flash event. This value is used to determine the appropriate level of PPE needed to protect workers from burns. The arc flash boundary is another important parameter. It defines the distance from the energized equipment within which a person could be exposed to a dangerous level of thermal energy. Workers should avoid entering the arc flash boundary unless they are wearing the required PPE. The PPE category indicates the level of protection needed to safely work on or near energized equipment. This category is determined based on the incident energy level and other factors. Workers should always wear the appropriate PPE when working on or near energized equipment. The date of the arc flash analysis is important because electrical systems can change over time. These changes can affect the arc flash hazard levels. It is important to ensure that the arc flash analysis is up to date. The name of the qualified person who performed the analysis is also important. This allows workers to verify the analysis results and ask questions if needed. The visibility and durability requirements for the labels are essential for ensuring that the information remains legible and accessible over time. These requirements help to prevent the labels from becoming damaged or obscured, which could compromise their effectiveness. In summary, the NFPA 70-2021 standard requires arc flash warning labels to be placed on electrical panels to inform workers of potential hazards. The labels must meet specific criteria regarding position, size, content, visibility, and durability. By complying with these requirements, employers can help to protect their workers from arc flash injuries. The standard goes further by stipulating that the labels must be permanently affixed to the equipment. This means using an adhesive or mechanical fastener that will ensure the label remains in place under normal operating conditions. Additionally, the label should be resistant to chemicals and solvents that may be present in the work environment. This will prevent the labels from being damaged or degraded by exposure to these substances. It is important to note that the requirements for arc flash warning labels may vary depending on local regulations. Employers should consult with their local authorities to ensure that they are in compliance with all applicable requirements. In addition to the information required on the label, it is also recommended that employers provide training to their workers on arc flash hazards and the proper use of PPE. This training should include information on the following topics. Firstly, what is arc flash? Secondly, what are the hazards of arc flash? Thirdly, how to identify arc flash hazards. Fourthly, how to protect themselves from arc flash hazards. Fifthly, how to use PPE. Sixthly, emergency procedures in the event of an arc flash. By providing training and implementing appropriate safety measures, employers can create a safer work environment for their employees. The arc flash analysis is a critical component of arc flash safety. It involves evaluating the electrical system to determine the potential arc flash hazard levels. The analysis should be performed by a qualified person who has the necessary knowledge and experience. The results of the arc flash analysis are used to determine the required PPE category and the arc flash boundary. The analysis should be updated regularly to reflect any changes to the electrical system. There are several methods that can be used to perform an arc flash analysis. One common method is to use a software program that simulates arc flash events. These programs can help to determine the incident energy levels and arc flash boundaries. Another method is to use a hand calculation method. This method is more complex but can be used for simpler electrical systems. Regardless of the method used, it is important to ensure that the analysis is accurate and up to date. The use of PPE is essential for protecting workers from arc flash hazards. PPE includes items such as flame-resistant clothing, gloves, face shields, and helmets. The type of PPE required depends on the incident energy level and the arc flash boundary. Workers should always wear the appropriate PPE when working on under-energized equipment. It is important to ensure that the PPE is in good condition and that it fits properly. Damaged or improperly fitting PPE can reduce its effectiveness. In addition to wearing PPE, workers should also follow safe work practices. These practices include, firstly, de-energizing equipment before working on it whenever possible. Secondly, using insulated tools. Thirdly, maintaining a safe working distance from energized equipment. Fourthly, avoiding working alone on energized equipment. Fifthly, being aware of the surroundings and potential hazards. By following these safe work practices, workers can reduce their risk of arc flash injuries. Arc flash is a serious hazard that can cause severe injuries or death. By following the requirements of NFPA 70-2021 and implementing appropriate safety measures, employers can help to protect their workers from arc flash hazards. This includes providing training, conducting arc flash analyses, using appropriate PPE, and following safe work practices. Taking these steps can create a safer work environment for everyone. It's also important to remember that the arc flash hazard is not limited to high voltage systems. Arc flash events can occur in low voltage systems as well. Therefore, it is important to implement arc flash safety measures in all electrical systems. The key takeaway is that arc flash safety is a continuous process that requires ongoing attention and effort. By staying informed about the latest requirements and best practices, employers can help to create a safer work environment for their employees and prevent arc flash injuries. Furthermore, the regular review and update of arc flash studies are essential. Electrical systems undergo changes due to equipment upgrades, modifications, or load variations. These changes can significantly impact the incident energy levels and arc flash boundaries. Therefore, arc flash studies should be reviewed and updated at least every 5 years or whenever there are significant changes to the electrical system. During the arc flash study, The qualified person will also assess the short circuit current availability at various points in the electrical system. This information is crucial for selecting the appropriate overcurrent protective devices, such as fuses and circuit breakers, to minimize the duration of an arc flash event. The faster the overcurrent protective device clears the fault, the lower the incident energy and the less severe the potential injuries. In addition to the label requirements, NFPA 70E also provides guidance on the selection and use of personal protective equipment. The standard includes tables that specify the appropriate PPE for various incident energy levels. It is important to select PPE that is rated for the maximum potential incident energy exposure. The PPE should also be inspected regularly for damage and replaced as needed. Furthermore, NFPA 70E emphasizes the importance of establishing an electrically safe work condition before working on or near energized electrical equipment. This involves, firstly, identifying all possible sources of electrical energy. Secondly, disconnecting all sources of electrical energy. Thirdly, verifying that the equipment is energized. Fourthly, applying lockout/tagout devices to prevent accidental re-energization. Fifthly, using voltage testing equipment to verify the absence of voltage. Establishing an electrically safe work condition is the most effective way to prevent arc flash and electric shock injuries. NFPA 70E also addresses the importance of electrical safety training. Employees who work on or near energized electrical equipment should receive comprehensive training on arc flash hazards, safe work practices, and the proper use of PPE. The training should be tailored to the specific tasks that the employees perform and should be updated regularly. By providing adequate training, employers can ensure that their employees have the knowledge and skills necessary to work safely around electricity. Finally, it is important to foster a culture of safety in the workplace. This involves encouraging employees to report potential hazards, to follow safe work practices, and to speak up if they have any concerns about electrical safety. By creating a culture of safety, employers can help to prevent arc flash and other electrical injuries. Arc flash events can have devastating consequences, including severe burns, blindness, hearing loss, and even death. The cost of an arc flash event can also be significant, including medical expenses, lost productivity, and equipment damage. By investing in arc flash safety, employers can protect their employees, their business, and their bottom line. To further enhance arc flash safety, consider implementing the following measures. Firstly, conduct regular electrical safety audits to identify potential hazards and ensure compliance with NFPA 70E. Secondly, use arc-resistant switchgear and other arc-resistant equipment. Thirdly, install remote racking systems for circuit breakers to minimize worker exposure to arc flash hazards. Fourthly, use infrared thermography to detect hot spots in electrical equipment, which can indicate potential arc flash hazards. Fifthly, implement an arc flash incident reporting system to track arc flash events and identify areas for improvement. By implementing these additional measures, you can create a more robust arc flash safety program and further reduce the risk of arc flash injuries. The ultimate goal of arc flash safety is to eliminate or minimize the risk of arc flash events. By implementing a comprehensive arc flash safety program, you can create a safer work environment for your employees and protect your business from the devastating consequences of arc flash. It is also important to remember that arc flash safety is not just a matter of compliance with regulations. It is a moral obligation to protect your employees from harm. By taking arc flash safety seriously, you can demonstrate your commitment to the well-being of your employees and create a more positive and productive work environment. In addition to the specific requirements of NFPA 70M and 2021, it is also important to be aware of other relevant standards and regulations. These may include, firstly, the National Electrical Code, or NEC, which provides requirements for the safe installation of electrical equipment. Secondly, the Occupational Safety and Health Administration, or OSHA, which enforces workplace safety regulations. Thirdly, state and local electrical codes, which may have additional requirements for arc flash safety. By complying with all applicable standards and regulations, you can ensure that your arc flash safety program is comprehensive and effective. The arc flash hazard is a serious concern for electrical workers, but it is also a preventable hazard. By implementing a comprehensive arc flash safety program and following safe work practices, you can significantly reduce the risk of arc flash injuries. Remember, arc flash safety is not just a set of rules to follow. It is a commitment to protecting your employees and creating a safer work environment for everyone. Incident energy reduction methods should also be considered. These methods aim to reduce the amount of energy released during an arc flash event, thereby minimizing the potential for injury. One common method is to use current limiting fuses. These fuses are designed to quickly interrupt the flow of current during a fault, limiting the amount of energy released. Another method is to use arc flash relays. These relays are designed to detect an arc flash event and quickly trip the circuit breaker, minimizing the duration of the arc flash. Zone selective interlocking is another technique that can be used to reduce arc flash hazards. This technique involves coordinating the tripping of circuit breakers in a selective manner, so that only the breaker closest to the fault trips, minimizing the amount of equipment that is energized. These incident energy reduction methods can significantly improve arc flash safety and should be considered when designing or upgrading electrical systems. Regular inspections and maintenance of electrical equipment are also critical for preventing arc flash events. Loose connections, corroded components, and damaged insulation can all contribute to arc flash hazards. Regular inspections can help to identify these problems before they lead to an arc flash event. Maintenance activities such as tightening connections, cleaning components, and replacing damaged insulation can help to prevent arc flash events. A well-maintained electrical system is a safer electrical system. Furthermore, consider the use of technology to enhance arc flash safety. There are many new technologies available that can help to reduce arc flash hazards. These include, firstly, arc flash detection systems, which can automatically detect and suppress arc flash events. Secondly, remote racking systems, which allow workers to rack circuit breakers from a safe distance. Thirdly, infrared thermography, which can be used to detect hot spots in electrical equipment. Fourthly, online arc flash calculators, which can be used to quickly estimate incident energy levels. These technologies can significantly improve arc flash safety and should be considered when upgrading or maintaining electrical systems. In conclusion, arc flash safety is a multifaceted issue that requires a comprehensive approach. By implementing the requirements of NFPA 70 M&S 2021, following safe work practices, using appropriate PPE, and considering incident energy reduction methods and new technologies, you can create a safer work environment for your employees and protect your business from the devastating consequences of arc flash.